As of this point, we have gone through finding zeros from intercept or factored form. We have gone through finding zeros from standard form and a few different ways to do that. What we have not addressed is how we find zeros from vertex form, although we have indirectly talked about this already. So down at the bottom of the page here, we're going to move into finding zeros from vertex form. And the way that we do that, again, is we're going to just reiterate something that we said a few pages ago, which is, once again, that the equation of the x-axis is y equals 0. Now, why is that significant? Well, actually, before we get to why that's significant, let's just, once again, illustrate that every point on the x-axis will have, as it shows here, a y-coordinate of 0. That is sort of the definition of the x-axis. The x-axis is the horizontal line on which all of your y-coordinates are 0. Now again, why is that significant? Well, remember that if y equals 0 means you are on the x-axis. When you are on the x-axis, that means you are, if you're talking about where a graph hits the x-axis, for instance, this line right here hits the axis here at point A, then you are talking about the x-intercept of a graph. So again, in the case of a quadratic that is graphed as a parabola, again, if we're talking about the points on the x-axis where, again, y equals 0, we are talking also about the x-intercepts. All three of these things are so far synonymous. And remember that x-intercepts are also synonymous with our zeros or roots. So to follow this line of reasoning, if we see a graph and we want to know where the roots or zeros of that graph are, we just look at the x-intercepts, because the x-intercepts are on the x-axis, and we know that on the x-axis all of our y values are 0, and again, that's the definition of a 0, the x values that make y equal to 0. We went over all of that on the second or third page of this section in a previous part of the quadratics videos. So what do we do when we want to find the x value where a certain function hits the x-axis? What we do is we throw in y equals 0. That's the simple way to think about this. If we want to know where a function hits the x-axis, at what x value a function hits the x-axis, basically what we would do is we would simply make y or f of x, again, those two are synonymous, so we make y or f of x equal to 0, and we solve for x. So for instance, in the case of this linear function right here, we're going to do another linear function on the next page, but we'll start with this one. If I wanted to know where this linear function hits the x-axis, in other words, if I wanted to know the coordinates of point A right here, all I would do is set y equal to 0, and then I would start solving for x, and I would get -1 equals 2x, dividing by 2, I get x equals -1/2, and that makes pretty good sense. We've got -1/2 comma 0. That looks about where that point is. -1/2 would be the x-intercept. -1/2 would be the 0 of this linear function. It would be the root of this equation, 2x plus 1 equals 0. So again, we throw in 0 for f of x or y, and we solve for x. At the top of the next page, we're going to do another linear function just to get our feet more wet with this. So in example 16, you can probably do this on your own. I would pause the video and try it on your own. In the xy plane, what is the x-coordinate of the x-intercept of this line? 2x minus 3y equals 4. This question is as simple as 2x minus 3 times 0 equals 4. Again, remember, if we want the x-intercept, we make y equal to 0, and now we have 2x equals 4. We divide by 2, we get x equals 2. 2 is the x-coordinate of the x-intercept of this line. By the way, if you want to find the y-intercept, you would just make x equal to 0. We talk about that in a separate section. Now, when it comes to quadratics in vertex form, and vertex form is reiterated at the bottom of the previous page where we just were. This is vertex form. All we do, if we want to find the 0 in vertex form or from vertex form, we simply set f of x or y equal to 0. We do have to remember an important point that we've made several times in the quadratic section up until this point, that when we're solving an equation in the form x squared or any variable squared equals some number or some expression, we have to account for, when we do square root both sides, the fact that the x value could be either a positive or negative value. Again, we've talked about that in a couple places, and that fact will come into play on questions like example 17, which we're going to do right now. If you want to try it on your own, pause the video. Example 17, in the xy plane, the graph of the function f shown above crosses the x-axis at a, 0 and b, 0. The question wants the product of a and b. So really, the question is simply asking for the product of the two x coordinates at the x-intercepts of this quadratic, of this parabola. So as always, when we want the x-intercepts or these zeros, we are going to make f of x equal to 0. So my equation becomes 0 equals 1/2 x minus 2 squared minus 8. And most of you should not have too much problem solving an equation like this because it is pretty basic algebra. I'm going to first add the 8. Remember, I'm trying to isolate the x, so I'm going to get rid of that 8 first. By adding 8 to both sides, I end up with 8 equals 1/2 x minus 2 squared. Further, trying to isolate that x, I'm going to multiply both sides by 2 or divide by 1/2, same thing, in order to get rid of the 1/2 in front of the parentheses there. So now I have 16 equals x minus 2 squared. Now, to further isolate the x, I do need to square root both sides so that I can get x minus 2 alone instead of x minus 2 squared. This is that slightly dangerous step where we do have to remember that when we are square rooting a squared variable or variable expression, as is the case here, we have to account for the fact that x minus 2 could either equal positive 4 or x minus 2 could equal negative 4. And that is because if what is in here is 4, well, 4 squared would give us that 16. If what is in these parentheses is negative 4, well, negative 4 times itself, negative 4 squared, would also give us 16. So the two relevant equations here are x minus 2 equals 4 and x minus 2 equals negative 4. I'm going to add a 2 to both sides here, and I get x equals 6. I'm going to add a 2 to both sides here. I get x equals negative 2. And therefore, 6 and negative 2 are my intercepts. They are my x-intercepts. They are my zeros. So these 2 points, a, 0 and b, 0, must be 6, 0 and negative 2, 0. It doesn't matter whether the a is 6 or the b is 6. The product, obviously, of a and b will be the same whether we do 6 times negative 2 or negative 2 times 6. Both of those will give us a product of negative 12, and that is indeed what this question is asking. My answer here is negative 12. So that is how we generally are going to find our zeros from vertex form. We simply replace the f of x or the y with 0, and then we use some basic algebraic skills, some basic equation solving steps to find the value or values of x, and we're done.